So this is lesson 10.6, day 3. We've been dealing with the parametric equations for the last couple of days. Yesterday's day 2 notes need to be used here, so if you have not gotten those video notes, you need to stop and go back to get those first and then come back to this. Otherwise, you need to have those notes out to refer to for today's video notes. So we're going to look at a couple of examples. Basically, we're going to be taking what we did for the day 2 worksheet and we're going to be going backwards. In other words, we're going to be given the equation in the standard form of the conic, or it might be having to complete the square to get it in the standard form, and then we're going to write it back as a parametric. So I'm going to give an example. Need to write these examples down. We'll do 2 different ones. So given this conic, first of all, we need to determine what conic it is. When we have the fraction plus fraction equals 1, the denominators are different. That means it is an ellipse. We determine the vertical or horizontal part of the ellipse by looking at the denominators, because we're also going to have to graph it now. And we look at the denominator and see where the bigger one is. That's always the a squared. So where it's located, that means it is a horizontal ellipse, horizontal major axis. And we need the center. We need what A and B are. Well, A, because A squared is 4, A is 2, B squared is 1, so B is the square root of that, which is also 1. The center, remember, is HK. H is always located with the X. K is always located with the Y. So we have the coordinate -3, 1 for the center. So I'm going to graph that. At -3, 1, we have our center. Because it's horizontal, we're going to go horizontally the A amount and vertically the B amount. And there we have drawn our ellipse, the horizontal ellipse. We need to give the parametric equations for these. So x equals y equals. Looking back at our notes, I'm just going to put a little reminder about our notes. Because it is a horizontal ellipse, I'm referring to my notes and looking at, it says x equals a cosine t plus h, and the y is b sine t plus k. So taking the information that we have from this problem, I'm going to plug that in. So x equals, the a is 2 times cosine t, and plus h. H, remember, the center is h comma k, so h is actually -3. Notice it's plus h in this equation, not a minus. So we actually have a -3 and or -3 in that part of the equation. B is 1, which we don't really need to write a 1. It would just be 1 sine t, which is just sine t, and then plus the k, which is plus 1. So our parametric equations are those listed, and that was how we followed from our notes. The next one is not given in the form that we needed in initially. So I'm going to write the equation given. So we can determine first off by looking at the squared terms to see what kind of conic it is. But if I have x squared and y squared both, one's positive, one's negative, automatically it's a hyperbola. Well, I'm going to get the squared thing, the y squared and the y parts together, because I'm going to need to complete the square. And then I'm also going to gather the x squared and the x portion. And then I'm going to need to complete the square. So The first one does not have a coefficient of the y squared, so we're going to be able to just start it off as is. I'm going to go ahead and put it in parentheses though. But the x has a coefficient, needs to pull out, and the negative. So I'm taking a -4 out of these both terms. So, and I put my plus blank into each part, and I'm going to have plus blank on twice on the right. The blank, remember, is b over 2 quantity squared. I'll put that as a little note. Blank is b over 2 quantity squared, just as a reminder. So half of 2, -2 is -1, squared is 1. And half of -4 is -2, squared is 4. Now on the right, on this first blank, the blank is 1. There's no coefficient out front, so it is a 1 that I in fact add to the right. The -4 that was taken out front of this one needs to multiply, and so that's a -16 that I really have to add on the right. We choose this because it factors as a binomial squared for both the x and the y terms. And when we add on the right, we get a 16. Dividing by 16 everywhere will allow for us to have it into the form that we need it to be in, to look like the parabola, the hyperbola that we knew this was going to be. So this is our equation that we first have to get into that form. We know it is a hyperbola. We know, because the y is first, that it is a vertical hyperbola. We know that the center is hk. Remember, h is with the x, k is with the y, so that is 2, 1. A squared is always the first denominator, so that's a 4 for a, b is 2. So this graph is going to, from the center, vertically the a amount, and horizontally the b amount. And we draw the diagonals, which are the asymptotes, through the center and through the opposite corners of the rectangle. This is vertical, so we have through the vertex approaching each asymptote on each side. We have our branches opening up and down. Now we have to write the parametric. So x equals y equals. Again, from the notes, I'm going to refer and look and see for a vertical hyperbola. It says x equals, whoops, let me start that over, x equals b tangent t plus h, and y equals a secant t plus k, by referring to my notes. So by taking my information, I'm going to plug into that equation for the parametric. So x equals, the b value is 2 times the tangent of t plus h. H, remember, the center is hk. It's the actual value, so that's a plus 2. The y equals a, which is 4, times the secant t, and plus k. K is 1, so we have a plus 1. So there are the parametric equations for this hyperbola. So your worksheet tomorrow will be more of the same, and that is all.